Hi, I'm Amber McKenzie. If you're here for the talk, if AI is right for you, then you're in the right place. So a little bit of my background. I'm obviously from the US, and I came from the University of South Carolina where I worked in mechanical engineering. We had the back end of a helicopter in a test stand in the parking lot, and we ran different components on it to test vibration signatures. And so I worked on historical maintenance records to try and match up what they did with the maintenance to the helicopters with the vibration signatures to see if we could predict when parts would fail, which is a pretty awesome start, I think. Then I worked at Oak Ridge National Lab in the computational data analytics group. So that's sort of where I got my start a little more in the data analysis and data science world. I did some startup work that didn't end well. And then I went to Dialogue Tech, where we looked at call records. So my background is in natural language processing. So I analyzed call records to determine trends for marketers to work with. And then currently I'm at PwC, which has a global presence, PricewaterhouseCoopers, and I am a manager of emerging technologies there. And so I kind of look at all of the different new stuff coming out and decide, well, I don't decide, but I offer my expert opinion on where we should go and the things that we should work on. And that's my very blended family there. All right, so we're going to start off with some stuff that is very interesting but less useful, and then we're going to end with some stuff that's a little more boring but more useful, because that tends to be the trend, right? The stuff that's useful is normally pretty boring, right? How many of you, by show of hands or shouting or however you're feeling like expressing yourself, feel like when you hear artificial intelligence, this is what we're talking about? Now, I imagine if I'd asked that question 3 years ago, that would be different, right? AI is sort of blown up recently, right? It's the new buzzword. It's the new thing that everyone's talking about. But before that, before everyone was talking about, if you talked about AI, right? We're talking about robots taking over the world. They're coming to get you, or they're going to be your best friend. One of the two, because there's nothing in the middle, right? They're either going to kill us or they're going to love us. That's how it is. And so that's sort of what we thought about. In reality, what is AI? AI in the traditional sense is sensing, or things that we as humans do that are fairly intuitive and things that we don't even think about, okay? We just do it, right? So we're talking about being able to pick out anomalies, okay? You guys can look up there and see, oh, there's a whole bunch of apples in a rock, right? But to a computer, being able to look at something that is, decently uniform in shape and look at the colors and all that stuff and decide what doesn't belong is not an easy task. Autonomous driving, that's coming up, right? Being able to think about when you drive. If you don't drive, think about, I don't know, when you're on a train. All the things that you have to process that you don't even think about. You're looking out and your brain is like, that's a tree, that's a road, that's a sidewalk, that's a kid on a bike, that's a dog, whatever. All of that stuff just comes in seamlessly, right? You don't actively think, oh, that is a tree, that is a dog. But the computer has to, right? It doesn't have any experience in that sort of thing. So it's got to take in all of that information that's coming in, flooding in, and process it and figure out what is important and what is not. All right, language, that's my specialization. Language is hard, very hard. And if you've ever tried to figure out how to spell English words, then you know it's hard, right? We have all sorts of different texts. We've got different ways of writing it. We've got different ways of saying things. We've got different ways of expressing meaning. If I tell my boyfriend it's cold outside, I'm not telling him it's cold outside. I'm telling him to get a coat. We know that, but how do you get a computer to know that? That's hard, okay? All of this, And then putting it all into something small. Think how big our brain is. This big, right? And it does a massive amount of work. And there are tons of research out there now trying to get our computers smaller and smaller and smaller, and yet do more and more things. Okay, so all of that is traditionally what AI is about. So this is a quote that's been floating around lately, right? And if anybody went to the talk yesterday on how to win an election, you know, that comment about statistics, right? We got a 50-50 chance here that humans, or that AI will outperform humans in all tasks in 45 years. And that's a very interesting statistic. One, I would love to know how somebody decided that in 45 years that's what was going to happen, right? I don't wholly believe it. We've made advances in AI, but we are not anywhere close on a number of very hard problems. But it's still interesting to think about, because while technology is sort of inundating us in our culture and sort of taking over all the things that we're doing, it's not necessarily. So think of like voice assistants, right? Everybody, Google, Amazon, Facebook, all thought that voice assistants were the future. And they were going to make one that was going to, you know, automatically order flowers for your significant other on your anniversary, right? They were going to notice that you had 2 conflicting meetings, and they were going to notify one of the people to try and reschedule it. And they were going to, did any of that happen? No. What do I do with my Amazon Alexa? I ask her the weather, right? I ask her to play some music, and my kids get her to set timers when they have to do something. That's about it. Now, there are some, other people are using it for some of the, the IoT stuff and that sort of thing, but they did not become the things that we were expecting, or that they were expecting them to be. What can we do now with AI? Boston Dynamics has done some awesome stuff with robotics, right? They are jumping and leaping and carrying stuff but a lot of that's physics, right? Yes, there's definitely AI under the covers where they have to react if you try and push it over. But a lot of that is like, okay, if one force is pushing me this way, then I've got to correct in this manner. It's not autonomously thinking, what should I be doing here, right? We're creating art, right? So this is, I believe it's Google's, they've got something you can go out there and just generate some art. This is some stuff that computers will do now, right? But that's where we're at, right? But when you talk about AI now, and why the reason that you guys, I only got a smattering of hands up, okay, is because now we have AI for business, right? Which is, in my mind, very different. So this is my very short soapbox, in that there is AI, general intelligence, that we are talking about when we're talking about trying to make autonomous cars, when we are trying to make robots to do things. And then there's the AI that we talk about for your business needs. In my mind, those are 2 different things. They use some of the same underlying algorithms and technologies, but in general, they are different. All right, so what I've got here, which is what I would point to, but then I'll tumble down the stairs and the talk will be over and you guys will miss half of it. So this chart came out, and it's interesting to me to look at sort of, we've got 3 levels of how successful different technologies have been, right? And then how far in the future we're looking to get to the next phase. And what's interesting from this perspective is, in my mind, how far up on the success scale they are depends on how useful they are to business, right? So on the successful one, we've got decision management and machine learning platforms, stuff to make everybody else able to do machine learning on their own. Virtual agents, speech recognition, right? All of those are pretty useful in the business world. And then in the middle curve, we've got some other things like robotic process automation, image and video analysis. And then on the bottom, poor swarm intelligence isn't getting very far because nobody wants to use it, right? So there's obviously different research pushes in terms of what are we going to use for business versus what is just kind of in the research realm, more for AI in the traditional sense. All right, so a brief look at the AI landscape. And again, all of this from now on is more on the business side, okay? So we've got what we're looking at for AI. We've got machine learning, computer vision, natural language processing, reasoning, search and optimization, and constraints and control theory. And so those kind of represent the large portions of what we're doing with AI for business use. And then there's sort of this idea that AI encompasses all of machine learning. Machine learning is kind of a tool there. And deep learning is within machine learning. And then under that, you've kind of got the algorithms and stuff that go along with it. All right. And all this feeds into you and your business problem, okay? Which is where we get to a little bit more of the boring side, because now you've got your business problem and you're like, all right, let me throw some AI at it. Right? And everybody wants AI. But really, there are 3 levels of technology, okay? We've got our traditional business intelligence that honestly represents the majority of business cases that are coming in, okay? And then we've got a smaller set that is data science, okay? Predictive is for data science. And then we have a much smaller subset that actually needs artificial intelligence. And so when you're looking at your business problem, that's where you have to kind of start your thinking, is not what technologies can I go and use, but really what level of technology do I need? So when we look at data science as sort of a hub, right, you start we've got the business intelligence, which is let me generate a report. Let me provide some insights, right, to my users that they can go and act on, which is what most people want and need. Then when you go to data science, we've got some traditional methods that are more statistics based, okay? So it's doing some reporting based on past statistics of your data. And then you've got the machine learning side that says, oh, okay, let's let the computer decide what are the features that needs to be considered for prediction. And those sort of span the data science realm. And then this is a pretty good depiction of how all of that fits together, okay? So we've got data science on the top, and that's sort of what's motivating a lot of this stuff, right? Is people have gone out and they're like, we've got massive amounts of data. What can I do with it, right? Can I just get information out of it? Can I do some prediction on it? Could I do something cooler? Okay, so we've got all that on data science, which feeds into things like data mining, machine learning, okay? Big data is not something I'm going to get into, but that's essentially just like all the technologies involved with handling data that is bigger than you're really able to handle right now. But then all of these things, machine learning, deep learning, all of that, they're sort of pushing the boundaries for AI, okay? The more we make advances there, the more we're making advances in AI for business. And generally, sort of at the bottom are some of the more advanced things like computer vision, natural language processing, generative methods, so generating data, generating language. There's a large market for generating synthetic data right now. So essentially, if you've got a business problem where all of your data is sensitive, you can't really do anything with it, well, then what can you do? You can either try and scrub it, which generally takes a lot of work and you're not guaranteed that you're going to get everything out, or you can create data that looks just like that data but doesn't have anything sensitive in it. So that's a new realm that we're working on with sort of some of the generative methods. When you're putting together one of your business problems, this is generally the expectation now. You're like, okay, well, I've got this data, right? And I collected it, I'm going to process it. And then once I got a clean data set, I'm going to go explore it. And then I'm going to throw it into some models. And then I'm going to show the results to my people. And the world is going to turn, right? That's sort of where everybody is, because we've all got some knowledge about data science. We've all got a little bit of knowledge about machine learning. So you think, oh, well, okay, I just got to pump it through this pipeline, right? The reality is that everybody misses the first two steps. Okay? This is sort of the reality of how your business problem should go. And I'm only going to cover the first two because essentially when you go down the list, you go down in decreasing difficulty. Okay? The top two are the hardest, and they are often the ones that are overlooked. The next ones, that's the ones that were in the chart. And honestly, once you have defined the first two, the rest of that is easy. I mean, I'm assuming you have, a data scientist or a machine learning engineer, because then if you don't, then it's not as easy, right? But if you do, and you've got the first two defined, then you just go and say, here, this is my business problem. This is what I'm looking to do. Go run it through some models. And that's the easy part, right? You just take the data, you clean it up, you run it through some models, you get some output, poof. But everybody kind of skips the first two. And this is how sort of that process looks like. The first three, the define and the design and the analyze, are all just a one-time thing, right? So we've got to define your problem, analyze what needs to be done and what level of solution we're looking at, and then explore the data. And then after that, it's a circular loop to develop the plan, train the models, report the results, go around again. Okay, so that's how that process generally goes. All right, so we're going to start with defining your problem. And I put this picture up there because it sort of speaks to me. All the time, I get this. I just need to do X, right? As if it's super simple and you'll come out, I just need you to cure cancer. Oh, is that all? That's cool. I just need you to get the computer to decide the outcome of this legal case. Is that all? Oftentimes, people come to you with this problem because they look at the big picture and they're like, I need to do this big thing. And I'm like, we can't. Essentially, because you've defined a problem that is hard for humans to do. So how do you expect me to just train the computer to do it? And so essentially what you need to start looking at are a few things when you start out, okay? First off, who is your business owner, okay? Because you guys know, as software engineers, generally you should not be the business owner, right? It's kind of a conflict of interest. So in a data science problem, you also should not be the business owner. There needs to be somebody there who is going to define for you what their business problem is, okay? And who the users are, right? That's what we do in computer science, in software engineering. We design for our users, for our business owners. Same thing in one of these problems. Then go and look at what is their current manual process, okay? AI in particular is all about automating something that people already do, that they spend a lot of time on. Now, if somebody comes to you with a problem that they only spend 1 hour a month on, don't make them an AI solution to take that out of their hands, right? These need to be things that they're doing repeatedly, that they're doing often. That is a pain point, right? Those are the things that we want to look at. And then ask yourself, okay, would everybody agree on the same answer? What is the level of subjectivity that we have in this thing? So if you've got an AI solution that's looking to determine a court case, right? Do you think that every judge, every person, every juror is going to answer that in exactly the same way? Probably not. So how do we then tell the computer whether it's right or wrong? Okay. Reusability. Again, that goes back to what I said. Don't do something that somebody just needs to do once. You're going to spend a long time making a solution that isn't going to be used very often. A waste of time, right? Error tolerance. This is one of the big ones, okay? I had a client come in and they wanted to set up something where we were analyzing legal invoices for them, right? So they wanted the computer take in the legal invoices, decide whether it was legal or not to be charging that, and make a judgment call. They wanted 90% accuracy across the board. They're like, that's what we want. And I'm like, that's not how any of this works. And so you need to define for your client what happens if the system is wrong, okay? Is it okay for us to give you a system that is right 70% of the time and have you check it, you know? Or if we get one of them wrong, is that really bad? For example, okay, if I have got, I've got something that is looking at x-rays, looking for tumors, right? Would you rather have something that finds 3 tumors and it is 100% right, but missed a whole bunch of them? Or would you rather have something that thinks it found 10 tumors and it really didn't find, 4 of them weren't, but it didn't miss out on any? Those are considerations, right? Do you want to pull back a whole lot of results, but maybe not all of them are the right ones? Or is it better to pull back a handful of results that are right, but miss out on some? Okay, so you've got to think, about these when you're defining your problem. Okay, you have to define your inputs and outputs. All right. We also had somebody come in and say, we want you to predict on whether a customer is going to default on a loan. And we have information about their credit cards and their magazine subscriptions and some random personal data. And I'm like, they come to us and they think that the computer is going to be able to do something magical, right? And in some ways they are, but you have to give them good data. You've got to give them good inputs, all right? And then you have to define for your client, what does the output look like, okay? Am I going to give you a yes or no that it's a default on the loan? Am I going to give you a probability, right? If I give you a yes or no, you've got to understand that there's a probability behind it and it might not be correct. Or do you want me to give you this probability? You've got to figure out what is going to go in and what are you going to get out of it. All right, okay. Next, you've got to look at what are the critical self-contained parts, okay? So that client that came to me and they're like, we need you to look at determine whether, this case is going to, how it's going to be resolved, okay? We have to take a step back and say, all right, what are all the pieces that goes in it for you to determine that? Okay, so we've got to collect the right data. We've got to first determine if they, who the plaintiff is and who the defendant is and maybe who they work for. Okay, so that's now all information that we have to have the computer to figure out. Then we need to look at, okay, is there a timeline that we can establish from the data? Maybe, right? What are the pieces of evidence and how sure are they? Obviously, I'm coming up with an example that would be very hard for a computer. But what I'm trying to kind of get at is that this is not just something that you feed the computer a bunch of data, right? And you're like, hey, computer, go figure this out, okay? And that's what a lot of people want. That's what we've sort of been conditioned. So you look at Watson, right? Watson comes out there and you just give it a question and it figures it out, right? Well, they have fed Watson so much data, right, to create that. But yet people I work with are like, let's go get Watson to do this. I'm like, that's not how it works. Watson ends up being extremely generic, right? Because they have fed it so much data. In order to make it anywhere specific, you've got to spend a good bit of time training it up to your specific use case. All right. But that's sort of what we've been conditioned to think, is that there are all these tools out there and all you have to do is hook them up and give them some data and voila, it works. That's not. So what you need to do is take your problem, this big problem, the simple impossible problem that they're talking about. They think it's simple, you know it's impossible, right? And say, okay, I can't do that, but let's break it down into a few pieces and say, okay, maybe we could do this. We could set this up as a checkbox, kind of like TurboTax, that you go in and answer some questions. And then that'll feed into this other system where maybe I deal with taxes. Maybe we can input some tax forms and it can, decide based on your questions, what might the answers be, right? And walk them through and say, these are the pieces. Maybe we'll start with this one and then we'll go to this next one and then on and on, right? But you've got to deconstruct it. Okay, just like a software program, it's got to have individual pieces, and none of those pieces can just be melded together into all of that one thing. All right, the last thing and often overlooked thing is success criteria. You have to be able to define, was the system successful and how the system was successful. And if you can't define that success, your project is going to fail, right? So if you cannot say, we're going to get out this determination and we're going to check it with these subject matter experts, and if it's 80% correct, we think that's good enough because then we can it'll cut down on this amount of time, right? If you can't define some sort of success like that, then your project's going to go nowhere. You're going to put something together and then everybody's going to be like, well, does it work? And you're like, well, it does this. And they're like, well, but I needed it to do this other thing. Right? And I'm sure none of you have ever been in that position where you've made a piece of software that somebody asked for, and then you're like, here it is. And they're like, that's not what I wanted. And you're like, but that's what you asked for. No, that's why we have business units. That's why we have requirements. Same thing for these problems. What makes it successful, right? And who determines that? It's probably not us. Somebody else is going to. So you got to make sure that they tell you what they need. All right. Next thing, then you can go to the data. Everybody wants to start with the data. They're like, oh, data, dive in. No, don't start with the data. Start with your business problem, then go to the data. Then determine, do I have the right data? Okay? Is it going to work for the thing? If I want to determine if the loan's going to default, but I have whether they bought magazine subscriptions because that just happens to be some public data I can get, that's probably not going to work, right? So you got to make sure you've got the right data for your problem. How do you tell the computer whether it's right? Okay, because you cannot create something without telling the computer how to create it. Okay, so you've got to think, based on my data, based on the outcomes that I'm looking for, how do I tell the computer whether it did something right or not? Okay, and that's a broad spectrum of things, right? That's as easy as telling it, it's giving you a yes or no and you tell it it's right or not, to think about computers playing Dota, right? Or out there playing, they've got computer simulations that are playing video games now, right? That's not an easy yes or no. How do you define for that computer if it did the right thing, right? Sometimes that can be a hard problem. And if that's a hard problem, then you got to work on that problem before you start your system. Also, sensitivity. And I can't stress this enough with any data project, right? Make sure you're not using data that has people's personal information in it, because somebody's going to come back later and completely ream you out, right? They're going to get mad. Lawsuits will ensue. It's bad stuff, right? Make sure, check with your legal department, check with your data department, whoever deals with those things. If you guys deal with client data, then somewhere in their contract, it's got to say what you guys can use that data for. And if it doesn't, start talking to your legal department to maybe get that put in there somewhere, whether you guys can use their data for secondary use, things like that, right? If it does have client data in it and you're not supposed to use that, then scrub it, okay? There are redaction programs out there, maybe synthetic data creation, whatever. But make sure that you're not throwing sensitive data into a model, because everyone's like, oh, well, once it gets in a machine learning model, it's fine. Not necessarily, okay? There are a lot of things out there now that'll reverse engineer your data from your model. there are likewise a lot of stuff out there now where people are doing algorithms that will essentially encrypt your data within the model, which is kind of interesting. But those are sort of in infancy, newer stuff. But just make sure, PSA type things. All right, so we've talked about, we defined your business model, okay? We looked at the data and we're like, all right, now I could talk about technology, okay? So again, this goes back to those 3 different areas. Don't try and shove your problem into just an interesting area, okay? It may be that you're trying to use, a jackhammer when a small chisel would work, right? So, think about, okay, what is the outcome that I'm looking for? Is it just they want some actionable insight from the data? Well, then maybe I can just go with business intelligence. Are they actually looking for more prediction? Maybe I can, do some data science predictive modeling. Or are we going to go a step further? Do I need to analyze some forms? Okay, do I need to get the computer to understand that this is the name on the form and this is the address on the form? Then do I need to go and roll that into something where it's analyzing the tax forms for me and that sort of thing, right? So think about sort of what level, and don't try and make it an AI solution. If it is an AI solution, by all means, because that is super exciting and much more interesting, the business intelligence. Sorry if I insulted the BIs out there, but don't try and shove it in there. And then this is more of like an informative thing, because I get a lot of questions about like, oh, well, where does machine learning fit in? Because that's the other big buzzword, right? And essentially what we're looking at, okay, is machine learning is a tool, okay? It is not by itself just a thing. It's a tool that data scientists are going to use, that artificial intelligence is going to use, okay? And that's going to be any of the type of classification models, of generative models, things like that. And then deep learning is when we take something like a neural net and we make it have a number of different layers, okay? Because the more layers, the exponentially more complicated it gets. And that's what we're talking about when we're talking about the deep learning stuff, okay? A lot of times, most of your problems are not going to require some really deep learning, okay? That's going to be things that get a lot closer to what we were talking about with humans and sensing and whatnot, okay? That's where we need deep learning. It needs more layers to try and we're like onions, right? Have all you guys seen Shrek? Maybe it translates differently. I don't know. But the more complicated it is, the more layers and stuff that you're going to need. So like vision and some of the deeper NLP stuff. All right. So here's sort of an overview of the different things that are involved in each of these solutions. Okay, so business intelligence is going to be things like aggregating data together, summing up different things, okay? Ad hoc reporting, looking at trends over time, okay? Those type of things are going to be in your business intelligence. A lot of the stuff that you're going to throw things into Tableau, right? And put up a visual and make a dashboard, okay? All of those are going to be your BI type things, right? Machine learning, data science, okay? We've got predictive, okay? So that's going to be some of your regression stuff, right? So we're going to take the classic example is housing prices. You pump in how many rooms it has, how many bathrooms it has, where it is, all of that stuff, and you produce a prediction on how much the house is going to cost, okay? That's just sort of your basic prediction type stuff. Time series. Okay, that's looking at things over time. There's actually, I saw a talk on time series analysis. So if you guys are interested in that, go to that. Whoever's speaking on that should give me some props for promoting their talk. But yeah, so that's looking at, okay, over time, how do things change? What are things doing? Can we then look at the future over time and try and make predictions there? Classification. So if you've got a bunch of data and you want to put them into different groups, okay, however you want to group them, that's classification. And again, you've got to make sure that your data lends itself to that, right? So if I wanted to group you guys into male and female, but all I have is, whether you're wearing shirt and pants, probably not going to be very effective, right? So make sure that the features that you've got lend itself to the prediction that you're trying to make. And anomaly detection, okay? What is different? One of these things is not like the other, okay? So looking at a whole lot of data, okay, we've got fraud detection, we've got security anomalies, all that stuff, right? So we're looking at what is the thing that's different from all the rest of them. Computers are really good at that, right? We're not so good, but computers have got that on lockdown. All right. And then AI, so generative stuff. If you want to have the computer generate some language, so that could include text summarization, okay? If it can include question answering, things like that. So what, if I want to, or if I, it's generating obviously art. We generate sound. They're now generating people's faces, moving, all that stuff, scary stuff out there, right? Have you guys seen the stuff where they take videos and they can make, so they've mapped it to where if you've got a video of someone, right, a bunch of them, and then you have some audio from somewhere else, that you can make the face move like the audio. All right, we're all sorts of faking people now, okay? Also, there are all those ones where they're like, is this a real person or a fake person? And you can't tell. I don't know, half of you guys might be fake. But generative stuff is creating stuff that wasn't there before. Deep learning, we went over deep learning. So anything that's going to require sort of a good, hefty neural network, right? And then computer learning, okay? So we've got all sorts of computer learning now. A lot of them, they stem around games. So we've got like chess, and we've got Go, and we've got Dota, all right? Because essentially what we can do is, a lot of those are decently rules-based. We can teach the computer the rules and let it go, and then it learns over time. It learns. I played 500 chess matches, and I won 300 of them. So I know that these ones, the rules or the moves that I use there are better than the moves that I used over there. And it starts learning over time. The more it wins and loses, the more it can make those connections within its little brain and, figure that out. So we do a lot of that, but then there's a lot of other ways that you can use computer learning. Okay, so you can have it redo your machine learning models and learn over time if you give it more data. And then multi-agent systems, okay? So using a series of different robots or agents or models, right, to interact and kind of produce results that way. That's another facet of artificial intelligence. All right. So let's go before I bring it up there. Once you sort of figured all of that out, right, the next thing is to determine what level of effort you're comfortable with, okay? Does that mean you want to do it all yourself, right? That might take a good bit of time, but in the end, you've got more control over your model. You've got more, ways to tweak it. Do you want to use some outside vendors, right? There's a lot of them out there now. We've got Google AI, okay, and Watson, which are a little bit more sort of hefty frameworks that you can just kind of plug in, and they'll help you out a good bit, right? They've put a lot of assistance in there. And then there's more stuff in the middle, right? So I would say Keras and things like Keras and PyTorch are sort of more, they're going to be frameworks that help you out, but they're definitely going to be a lot more hands-on. So you've got to kind of decide then, all right, hey, I've got all this stuff set up. I've talked with my business people and all that stuff. Now, how much time and energy do I want to spend on this to get what I need out of it? Okay. And these are some good places to start if you want to start looking into doing it yourself. All right. So then what? Okay, you've put together your AI solution. You're like, I'm done. I threw this picture up there because so my second love is cognitive neuroscience. If I ever go back and get another PhD, that's what I'm going to do it in. But I don't know if I'm ready for that. That was a lot. And so I put it up there, not to say necessarily that we are headed in the way of the next step is brain-inspired computing, but we are headed in that direction. And so I know that a lot of the stuff that we're doing, especially in computer learning, is heading us towards more brain-inspired computing. So how can we make computers more like the brain? So that's where artificial neural networks came from, right? So that's what they were trying to mimic, is the computation that we do in our brains. And so, trying to head us closer to that, because our brains are like these massive computers that work on a very small wattage of power, but yet do millions of computations. And so it's amazing. But in reality, incorporating new information, okay? So if you've put together models, if you've come up with this solution, okay, you've got to decide, is that solution going to stand the test of time? Is that something that I put together and the data is not going to change very much? It's all going to be fine. In tax, you can't do that because the tax forms change every year. So we have to constantly be renewing what we're doing. So you're going to want to take new information and incorporate it into your model, rerun your model, make it more appropriate to the data that's coming in, okay? There's also things like transfer learning. So if you make a more general model, then you can bring in new data and sort of just transfer some of that model over to the new domain. Providing feedback, okay? Don't just send this out and let it go to the masses and not hear what they say, okay? Because you may have tested your model in a number of different ways, right? And it was like 80% every time. And then you send it out to the real world and they're like, it's wrong all the time, right? Make sure that you get feedback from the people that are using your models, that are using your solution, and say, hey, what are the things that are wrong? How can we change this? How can we make it better? Okay? And then analyzing the output to evaluate the model, okay? That needs to be a continuous thing, okay? So you've got to say, all right, what is the output that I'm getting based on what I should be getting out of my model, okay? And maybe those aren't the same things, or maybe that changes. Maybe you were giving them a yes or no and then they wanted a probability. Make sure that those things sync up with what you're looking at, okay? All right, so in recap, just to say that we started with AI in general and how that's different from business intelligence, okay? And then we moved to the main things that you need to do when you start a project are your problem definition, okay? And then designing and the level of technology that you need, right? And then we went through sort of the different types of technologies. But in general, just spend some time with your project, okay? And make sure that what you're trying to get out of it is something that is, one, feasible, and is two, what your business users are looking for, and is three, is using an appropriate level of technology, and that you're not just sort of going out there and going to put together something that nobody's going to use, right? Unless you're doing research, because that's what research is most of the time, making something that nobody's going to use. But then write a paper and get some credit, right? That's how that goes. This is how you get in touch with me. Thank you very much. I'll take some questions if there are any. Oh, behind the speaker. Yes. Mm-hmm. Right. No, that's a great question. So the question was whether if you've got a solution and you go and you put a solution together and you bring it back to the business people and it's not what they're looking for, are we overselling some of these solutions to our business users? So generally, I find that happens with people who have not learned enough with technologies. So my second soapbox is that uh, if you ever get to the point that you feel like you know it all about a subject, you're probably dangerous. Because I think, as most of you know, if you get to be an expert in anything, once you learn enough, you turn this corner and you're like, oh my gosh, I don't know anything, right? You've all been there. You're like, oh, I know everything about CSS. And then you learn enough to know that there's a whole lot you don't know. But there are a number of people who learn just enough to think, oh, I know enough to do this, right? And they never learn enough to turn that corner. And I find that those are the people who tend to oversell things. I'm considered an expert in natural language processing, but I know that I don't know a ton. And when I tend to be way more conservative and be like, no, we can't do that. No, we can't do that. No, we can't do that, but we can do this, and then build out a solution that way. But I do think, especially with the buzz that's out there, that there are a lot of people out there just trying, oh yeah, we can throw some AI at that. Oh yeah, we can totally do that. Oh yeah. And then they'll munge the data, they'll make it look great, and it ends up not being what people want. So I completely agree that is a fear. And my recommendation has been to everyone, if you're so we have a lot of people who are learning data science and machine learning, and they're like, oh, there's so much to learn. How do I get there? And I'm like, pick something, pick a small thing and learn a bunch about that. Something that's going to be really useful to your business model, and learn that. And then if you need to branch out, you'll start to know where you need to go. But then at least you're learning enough to not oversell it. Sure. Hmm. So he asked if what I thought about the emergence of quantum computing and whether I work on that. So I follow what's going on with quantum computing. I follow much more what's going on with neuromorphic computing, both of which are sort of different areas that are both sort of trying to emerge. The main problems that we've got there is that we've got a whole lot of computer science theory and framework that is von Neumann related, right? And so it is all, we all know how to create software programs and systems that fit that model. And then there's a different model for quantum, and then there's a different model for neuromorphic. And the problem is that quantum is never going to just come and take over, right? Like, we're not just going to suddenly like, oh, we're all just shifting to quantum computers. But they're going to have to find a way to meld some of those. So we're going to have to find a way to be able to do some of the programming that we have now on quantum computers, even though that's not really, how they're made up, but we're going to have to find a bridge. And so until some of that stuff gets sorted out, those two are just going to stay fringe, because you guys aren't going to pick them up, right? Like, you're not going to go and completely redo all of your learning to learn quantum computing and dive all in on that. There are a few people who will, but you guys aren't. Well, if you are, I'm sorry, you might, I don't know. But that's sort of what I feel about those two, is that until we get some sort of mutually universal framework that we can sort of like what we did with GPUs, right? When GPUs first came out, you had to do very specific programming. You had to tailor all of your computation to move the memory around and split it up over the cores and all this stuff. It was a pain, right? Well, they had to make it to where using GPUs was seamless. And now we can use them to speed up our computation fairly painlessly, but but we don't think about it, and that's what they're going to have to do with those. Any other questions? Well, thank you so much.